Hi, my name is Ron Dorn, and I'm here to explain to you my perspective on two of the Grand Canyon Geomorphology Labs, rate of change 1 and rate of change 2. I decided to package these up together because I think they fit well together and I want them to be seamless. So I'm showing you my perspective on the labs as an instructor. This is how we've got a view of when the lab is rolled out. When you look at the landscape of the Four Corners region of the Colorado Plateau, it's an exciting landscape portrayed here graphically by Ted Oberlander. There are cliff retreats going on. There are canyon incisions going on. There's the lowering of the landscape by erosion. And one way to look at it, and that's the way this lab does, is that we're doing science trying to explain what we're seeing in a landscape like the Grand Canyon. And there are three different sorts of sets of processes that are happening. The first is erosion of the upper plateau that a canyon is cut into in a downward direction, lowering the elevation of the plateau, with the example being the Painted Desert, where the rock is so weak, like shale or compressed mud, that no deep canyons can exist because everything is eroding away too fast for canyon formation. That is one set of processes. Another one is where a river incises downward. There's downward erosion called incision. And the view that you see here is of Marble Canyon, where the Colorado has sliced almost straight down, creating a deep gorge. And this is when river incision is faster than erosion of the plateau downward. And it's also faster than the third set of processes, which is the widening of the canyon by cliff retreat, by landsliding and the development of tributary canyons. So Marble Canyon is a place where at the bottom, incision is faster, giving you a gorge. And at the top of Marble Canyon, cliff retreat is faster, giving you a broad canyon. And in the Western Grand Canyon, incision and cliff retreat are somewhat in a balance. So this is what scientists call a conceptual model of understanding. We're creating a theory, maybe a fantasy, maybe reality, but it's a way of looking at it and thinking about it. So this first part of the lab has you go to different locations in the Grand Canyon region. For example, we might send you to the Painted Desert, where plateau erosion is too fast to create a canyon. We might send you to Marble Canyon, where there's super fast river incision. Or we might send you to the Western Grand Canyon or to the middle. So we give you in this introduction three examples of where you're dumped in the Grand Canyon. And here's your avatar in the first example. And the explanation we have for this example is if you look to the left or to the right, the east and west of the avatar, you can estimate that the canyon width looks to be about the same as the canyon depth. So when you have incision going on and you have widening going on that's about the same, and you have a high plateau, the answer is that the rate of widening and the rate of incision would be about the same, and the rate of plateau erosion would be much lower. In the middle example, right away, do you see that the canyon's a little bit wider than it is deep? So you still have low rates of erosion up on the high plateau, but the widening is faster than the deepening. And in this bottom example, I hope you can see that it's a slot canyon and it's really deep and it's not so wide. So the rate of widening is slightly less than the rate of incision, but still much lower than the rate of plateau erosion. So in this first lab, you have these examples and then Canvas will spit out random coordinates in which you try and do your best and answer your assessment of which one of these models looks correct. We think it'll be on the easier side of things. So now let's go to the rate of change part 2. And you start out with the same broad example and the same conceptual model, that where you are can determine the balance between river incision or downcutting, canyon widening, and plateau lowering. And this is just in our heads. The question is, what happens if we actually measure it? Does this way of thinking about it fit with scientific data? And that's what this lab is about. There's just one question you have to do, but there are 4 parts to this lab. The first part is you measure the lowering of the plateau. The second part is you measure the rate of river incision. The third part is you measure the rate of canyon widening. And then the fourth part is you compare these rates to the conceptual model you did in the first part of the lab. And that's really what science is about. And so here is an example question with the coordinates you're given and the correct answers. And in this example, the correct answers, you're getting low rates of plateau erosion, pretty good rates, 385 meters per million years of canyon incision, and almost 3,000 meters per million years of canyon widening. So in the first part, you're instructed in this example, you're instructed to go to a lava flow on the south rim of the Grand Canyon that's covering what's called the Shinarump and the Moenkopi formations. And these rest on the Kaibab. This is a unique chance where a lava flow has frozen the landscape. And we know the age of the lava flow is at 9 million years. So what you do is you go to the top of this lava flow, you write down the elevation, you go to the bottom of the lava flow, you write down the elevation. You have the difference in height. You know the age of the lava flow. So you simply take 180 meters divided by 9 million years. That's 20 meters per million years. And the way to think about this strange unit of meters per million years is to convert it to something that makes sense. 20 meters per million years is the same as 20 millimeters per 1,000 years. And that's the same as 2 centimeters per century. And since 2 centimeters is a little bit less than an inch, this lava flow indicates that the plateau is eroding at an age of less than an inch in 100 years. So that's pretty small rate of erosion. And then you get taken to 2 sides of the Grand Canyon, 2 rims of the Grand Canyon, and the river in between. And what you'll do is you'll measure the elevation of the 2 rims of the Grand Canyon and what are called the X and Y coordinates inside the game. And you measure the elevation down in the bottom of the canyon. So that gives you the information you need to calculate the rate of incision and the rate of widening with a little bit of extra information. You need to know the age when the Grand Canyon started to erode. And that's been determined by the Arizona Geological Survey to be 4.8 million years ago. So the Grand Canyon started cutting 4.8 million years ago, and it reached its current position by about 1.2 million years ago when there's a lava flow that reached the current position of the river. So amazingly, the Grand Canyon started eroding 4.8, pretty much stopped at its current elevation way down low at 1.2. So it took 3.6 million years to cut the Grand Canyon. So you'll use 3.6 million years for the time it took for the Colorado River to incise downward. So the instructions in Canvas walk you through the idea that to figure out how much incisions occurred, you simply average the 2 sides of the canyon, And the instructions walk you through that. And you divide the depth of the canyon by 3.6 million years, and you get a rate of 385 meters per million years, which is about a rate of about 1.25 foot every century. The last piece of the puzzle is where you figure out the width of the canyon and how fast the canyon has been widening. So to do this, you're going to learn about the Pythagorean theorem. Oh, you probably already learned about it in middle school. See, the game has X and Y coordinates in meters, starting in the southwest. So each position is an X and a Y. And so when you have two sides of the canyon represented, all you have to do is figure out the difference in the X and the difference in the Y and plug these into the Pythagorean theorem, and you'll know the distance between the two rims of the Grand Canyon. So the instructions walk you through how to do this. And so you've got the width of the Grand Canyon, and then you simply divide that by the 4.8 million years that the canyon has been widening, because the canyon started to widen when the Grand Canyon started to form 4.8 million years ago, and you get a rate of canyon widening for the whole thing. So you answer the question in 4 parts, and this is what it comes down to. Just a small paragraph, a lot of work to figure out a small paragraph, and then you can actually see whether or not the conceptual model on how the Grand Canyon looks, whether it's deep and narrow, whether it's wide and not so deep comparatively, or whether the plateau is eroding. Which one of these perspectives is correct? Canvas provides lots of detail, lots of specific instructions. I just wanted to overview this for you.